Hello. Oh, hello, I'm Bas Hamer from PossumLabs, and today we'll be talking about the contribution guide for the PossumLabs DSL.core project. So we're actually going to dive into the source code. If you are not planning to work on the source code, just skip this, don't look at it. So let's go and take a quick peek and see what we have going on. So there's a couple of things that are going to be not too surprising. This is going to be distracting. One moment. Well, Visual Studio. There we go. All right. So let's take a quick look. So you have configuration. Configuration that shouldn't surprise you too much. This is primarily dealing with how we interact with configuration. It uses some of the Microsoft APIs. We'll go through this in a moment. Exceptions, this is dealing with the execution manager as well as with exceptions. This allows you to catch an exception inside of Gherkin. It allows you to catch one single exception and check the contents. So it's a little bit of some wrapping code in there to help support that. Files, this is dealing with IO type deals and file objects. Fluid data creation, this is something you haven't seen in the tutorials at this point. This is dealing with an API to create pretty language to create your data. Mostly intended for unit tests, not intended for Gherkin-based testing. Logging, self-explanatory. PossumLab, this is another page that you haven't seen before. This is also on the tutorials. This is PossumLab is an application. It's a web-based application. Intended originally to be an editor for Gherkin files. It can do that, it just doesn't do it well enough. And at the moment, one of the things that might be more promising is that it's actually going to be a reporting tool for Gherkin-based testing, so that you can actually see where your tests have gone and diagnose test failures easier. And also answer questions around coverage, which has been an interesting thing I've been digging into as of late. Threading, just helpers for threading. Validation, this is the validation logic, validators and things like that. And variables, this is the stuff that's dealing with the supporting the dot notation and the resolution, so it's the repositories and the resolver and things like that. And these things just didn't have a good home. Cache type accessor, this makes reflection a little bit faster. Comparison defaults. Oh, this is just a way that you can override the string comparison culture for certain parts of the system. You go away. Come on, buddy. Datetime manager. So this is an interesting little creature. So it's an IOC version of DataMDOT now, right? So one of the things that I figured out is that there's lots of systems that don't particularly like it when data gets stale, right? Because there's a lot of calculations that are based upon now, but it's also very hard to keep your data up to date. So one of the things that this allows you to do is to run your tests under the assumption of it's last Tuesday, right? So you can override how it determines what is now by using this particular construct. It's something I've used in a couple different places over my career, and looks like some of the stuff is using it. Equality comparer. This is a generic equality comparer. I'm sure people have encountered this guy before. So you can actually pass it into different types of filter methods. Extensions, you'll find lots of extensions. Log formatter, what this does, it makes sure that you don't have more than 25 items, or it grabs the first 25 or something like that, and it does comma separated, otherwise it does new line separated. These you'll find in lots of different places. So there is this method called .any on enumerable, which I love. I think it makes way cleaner code. The thing that I was missing was .none, .many, and .one. So I added those. There's different implementations of that. Some conversion logic is numeric type. Try convert. This is one of those magical methods that tries to the best of its ability, convert one type into another type. This is primarily helping with cases where we have to move things that show up in the system as like an int 16, and we want to move it into like an int 64 or back and forth, depending on what the data types are. This helps resolve some of these things. There's a lot of reflection you're going to encounter in this particular project, so just a heads up. On air continue. Right. This is something that you probably hope to never, ever see in C# code, but it does exactly what you think it would. It just swallows exceptions from a method. It's only used in one particular case, so don't panic too much. Gherkin exception. This is a specific exception type to illustrate that, hey, there's something in the Gherkin we can't really process. So this is indicating that, like, hey, your feature file is wrong. On error. Oh, continue. Fantastic. It's just a different way to use that same method with prettier syntax. You will find lots of things like this. This particular one apparently seems to be not actually being referenced. Parsers. There's a bunch of regular expressions that have been put together that are probably being used in some of the places where we check whether or not something is literals, is whether or not this ought to be regular expressions. This is part of the validation logic. Performance extensions. Is any of this being used? I don't think this is being used very much. So if I were to guess, this is abandoned code. Resolved string. This is just a wrapper around string. It has all the casting and all the other stuff you need to implicitly go back and forth to make your life easy. That's because it allows you to create repositories of resolved strings and treat them like strings. That's really the biggest reason for it. Scenario metadata. This is a little wrapper around the metadata for a particular scenario. So it has the feature name, scenario name, metadata, whether or not an error is present, and of course it's going to be a function because you need to tell it how to get that information. So here's one of the things that's worth noting, and that is that we do not at this point have a dependency on SpecFlow or any kind of language. That doesn't really show up until you get into the Gherkin project. So just keep that in mind, is that there are some, things in here that we possibly could have used the SpecFlow project for. But at this point, it wasn't worth it. That's also because of some parts of the PossumLabs DSL core project that you can use relatively well without actually needing to be working in Gherkin. A supported exception just says something isn't supported. Pretty much it. All right, so that offers the basics part. So configuration factory. All right, so what we're doing here is we're primarily relying on the Microsoft extension configuration stuff. And what we're doing is we're effectively looking for different ways to resolve configuration values. So this way we can load stuff from JSON files and overwrite them with the values that may have been provided as system environment variables. Nothing too fancy in here, right? So here we do the environment variable option. If it doesn't work, it doesn't work. Like this is one of those cases where it is for something that is loading configuration values. We don't expect this code to run more than once per test, so I'm not really worried about the performance impact of having exceptions happen. And here you see some of these conversion methods in here as well, where we try and manage the data coming in and mapping things to the way they ought to be. attributes, whether or not something is a configuration member. It's either a property or a field, and it has a path, and that effectively tells you the path where things are being located, right? So when we look at the movie logger config, I believe this has it. So this pretty much tells you like, okay, well, this is where these things ought to be in the config file. And it's underneath this movie logger object, right? So it kind of tells you how to navigate the JSON files to figure out exactly where things are located. No. All right. So it's image logging, movie logging. So difference between image logging and movie logging. Image logging adds text to images just to provide some more context to what's going on. Movie logging is talking about taking a number of images along with logging messages, putting them all into a timeline so they can be converted into a movie. And then you can turn on the subtitles if you want to see exactly what messages were being logged at different points. Right, so image logging just creates a single image, and movie logging creates a movie, right? It's not that exceptional. Action executor and a retry executor. So the retry executor is something that is primarily used in the web project. So what we're doing is, for instance, when we are looking for a particular item on a page, we'll retry that for a certain amount of time, waiting for that item to show up. Right? We don't wait on Selenium because we don't necessarily know what XPath we're going to be using. So we just keep retrying until something works. And the action executor is primarily used as a delegate. And what it allows you to do is to run something inside of this execute methods. Then when a exception is expected, so expects exception, and we didn't have an exception already, then we can actually log that exception and capture it and just keep on running. And that way what you can do is you can effectively have one step which flips a switch that says, hey, expect an exception. The next step, if it throws an exception, will just gobble it up. And then what ends up happening is we end up making it available for testing. And you see this is used in a bunch of places, like 74 references. This is being used in lots of different actual step implementations, and it pretty much adds an additional piece of functionality to your domain-specific language. All right, retry executor. All right, it has a not used nearly as much. And this is effectively retrying for an amount of time. It's a default time span. Right, so the retry executor, it does require a function as an argument for the thing to work right. I also wanted it to work for an action, so I created a function out of my action, which just returns 42. This 42 doesn't go anywhere because nothing cares about the output of this thing. But this way I could reuse the same code for both an action and a function. So that is execution. Files, file manager, iFile manager, and in-memory file. So file manager, this guy is primarily used to keep track of files and to write stuff to the file system if you have to. So there's a single place that can figure out where things ought to be written to. And this is important when it comes to, like, taking all the files that are being created by a particular test case and putting them into a logical place that makes sense related to the name of the test case. That's pretty much the entire purpose of this thing. And the way that it does that is it creates a new folder with the feature name, scenario name, example name. This information is usually not available to you if you're running in SpecFlow. And then a date timestamp. So that way, hopefully everything is in a safe place. And then we strip out a bunch of the special characters and just replace them with spaces, trying to prevent any issues with file systems. But that's pretty much all that this guy does. In-memory file. Now, we don't always need files to be written. The time when we really care about files on the file system is when we're trying to figure out what went wrong. So for passing tests, it makes sense to sometimes just keep your files in memory and then write them to disk when you need to. So that is what this guy does. Right? It just has an on method where we actually log the file, and that file ends up in the file system through the logger. All right, fluid data creation. This is a fairly large amount of code, and this is something you have never seen before. So let's first look at what the test cases look like for fluid data creation. These are the different types of objects, factories, blah, 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 blah. Where's the test? There we go. Okay. Here we go. Here's a nice example. So this is the language it allows you to do. So you have a setup object, which is part of the fluid data creation. And it has an extension, has a method called with parent object. We call this thing P1. We use the configurer, and now we specify this parent object. And then we can even specify on the parent object that the parent object should have child object. Right, so this is kind of the language you can use to define your data hierarchy. And what you end up looking at is something that looks very similar to the hierarchy you'd expect. Right, you're just newing up objects with an object with a little bit of additional syntax because of the C sharpness, and we end up creating this data behind the scenes. And then the way that it works, it will actually create things when it has to have the IDs available, right? So you can write fairly clean configuration code. That's pretty much all it really supports, right? So we can have multiple children, named children. And can you have multiple? Yeah, so we can also just add a child object without being associated, or we can just get the child from the setup. Yeah, this is not really being used by many people, and it probably isn't very useful. So chances are this may go into its own project at some point. I don't know yet, but for right now it lives here, and it will probably stay there for a bit. But yeah, that's what fluid data creation does. So if you want to look at the APIs that are involved in that, feel free. The only thing that is worth really looking at is, I think, this one. Yes. This is a line of code that every time I look at it amazes me because it actually compiles. So a public AppSci class setup base of type C, which implements iSetup, where C implements setup base of C. Yeah. I'm shocked this works, but it works and allows you to write really pretty APIs. So that's pretty much the highlight of the entire folder, and I'm going to skip over the rest because I don't quite know where that's going to go at this point. If you end up in here and you run into issues there, feel free to reach out to me. I'm more than willing to set up a video conference and we can talk through it. Logging. Default logger, image logger, interfaces, image logger, movie logger, SRT logger. SRT is the extension for subtitle files, and YAML log formatter. I found that formatting file data, larger objects into YAML, is pretty on the eyes when you have to look at log files, and I've pretty much used it as a default. But of course you can switch it out because it just implements the right interface, right? You can just switch out your log formatter if you want to. The PossumLabs project. What does this do? So yeah, PossumLabs is a thing that it's a web-based application. Originally was supposed to be like an editor, which allowed you to from zero get started in creating test cases using Gherkin. And the whole thing would be through user interface that was more suitable for business users rather than what we're looking at right now, which is Visual Studio, which is not suitable for business users at all. Never really got it to that point. Got it pretty far, got a fair amount of stuff working. These are some of the hooks that make things work well together. So I provide autocomplete information. So this is effectively for the editors in this web application to gather autocomplete information. Debugging information. So this is for running tests. So when you're debugging tests in this web application, you can pipe information back and forth using this. Well, only towards the application, of course. I require a keep alive signal. So this is just making sure that we don't kill a running process because we didn't communicate with it long enough. So we can just keep sending pings back and forth. And then we have some attributes to help out as well. Yeah, none of this is really being used at this point. But I still have hopes that I can make that thing do something well, rather than all the things it does right now that are not done all that well. Threading. Parallel first or exception extension. I believe this is being used in the web project where we are leveraging this to run a bunch of different XPaths in parallel. Now, when you're running XPaths in parallel, we want to honor the order of the XPaths, right? So if we have a scenario where XPath number 4 has a hit, and XPath number 5 has a hit, and XPath number 6 has an exception, then that is a successful evaluation, and the result should be the result of XPath number 4. But if you run things in parallel, what can happen is that you have the exception come back first, then XPath number 5, and then XPath number 4, right? So you have to make sure that as soon as you hit something that is a stopping condition, which is either something return the result set or an exception, that anything else prior to that, which has a higher priority, has to finish as well. So that's what this code does, and it handles the parallelism aspects of it. That's really all it does. But because parallel code is a nightmare, it has its own little place to live. Validations. So we have data table validations and normal validations, validation exceptions, validation extensions, and validation factory. All these things pretty much do what they ought to. Let's take a look at the extensions to make sure there's nothing really weird in here. Yeah, it just has some additional syntax helpers in it. Contains, validate, and just validate. It just makes it prettier to write your code. So the validation factory. So it builds a predicate, and then when you're in the predicate, now we start using all of these different regular expressions we saw before. That's how it figures out what kind of predicate to build for this. Right, so you have something that checks for nulls. This is a test. This is a regular expression. This is a literal. This is substitution, number, percentage, money, JSON. Test, I believe, is just greater than, less than. So it's kind of like a Boolean expression type deal. So yeah, that's kind of what we do in here. And then we have different predicates that we use, right? So percentages, numbers, nulls, literals, regular expressions, JSONs. And then we have tests where we have equal to, about the same. This is mostly to handle rounding issues. Again, this is something that isn't covered in the tutorials because I'm not exactly happy with it, but I also kind of know that I want something here that does this. I just don't like the solution yet. Not equal to, greater than, equal to, less than, or greater than, less than, equal to, less than, all different versions. Or exceptions when we don't know what's going on. One of the things to keep in mind is whenever we are parsing Gherkin and we're trying to interpret it and you don't know what's going on, provide a good exception, right? This is the compare we found. This is all we support. Because if you don't provide decent exceptions in this part of the code, then it becomes very hard for people to figure out what they have to change in their Gherkin to make their test run. And, anything that prevents people from opening questions because they can't find the answer, if we can do that with better exception messages, that sounds amazing. So let's do that. Data table validations. A lot like validations, just way more complex because you now are dealing with entire data tables. But I believe it's built upon the same basic concept as validation. It actually inherits from it. It just handles more complicated objects. Okay, variables. Welcome to the big mess. Actually, it's not that big a mess. But it is the most complicated code. This is going to be very heavy on recursion and reflection, so just a heads up. And the first thing we probably want to cover is the extensions. So we have this concept of a value member info, which is interesting because you probably have never heard of that thing. That's because it lives in here. In C# you have something for a property info, which is a reflection construct. And you have a, actually let's go into this good definition. Yeah, you have either a property info or a field info. These two things are almost the same, but they're very different behind the scenes, right? There's no common interface between these two. So this is a facade which is built on top of property info and field info. So I don't have to write the branching logic all over the place for dealing with properties and fields. So we have this value member info. Of course, value info already existed. So that's why it's called value member info. That's why there's some extension methods. And those extension methods effectively are just providing versions of the reflection constructs you used to, except now they're applied on these value members rather than on properties and fields. So you don't have to combine the two or first check properties to see if you can find a match and then check fields. Just treat everything the same at the code level, and then below the hood we switch in between them using this particular value member info object in between. So that makes life a little bit easier there, as much as things are going to be easy when we're dealing with this much reflection. Anything of particular interest in here? There's the existing data manager lives in here. This has a couple of things that are interesting related to what JSON it looks at. Oh no, this is not the one. Is it? Get all types of. Yes. Okay. So we look in the current assembly we're in. Gets the exported types, unions, reference assemblies. Get all the export types from them and get all of that stuff combined, and then we check whether or not it's assignable of T. So this is how we find all of the entities. Reflection has changed more in .NET Core than I'm probably aware at this point, and I'm aware that it changed quite a bit from what I was used to. It's a little bit tricky when you start messing with this code because you really do have to test it on both Windows and Unix. There's a couple of reasons for that. One, the assemblies that end up getting copied into your output folder may not be assemblies you're able to reflect into, first of all. There might be some stubs in there that effectively are being replaced by the operating system, but if you do it using reflection, you don't quite get what you expect. So just be aware of that. And you have to do some additional work to get there. And I believe there's like a loading context. I don't see anything in here right now. I believe at one point I had a loading context that helped out with this, but I guess this does the job. So yeah, just be aware that if you start digging around in this particular code, that you may be learning a lot more about reflection than you intend, and you'll learn a lot more about recursion and dynamics. This is probably one of those areas that it'd be easier to dive in and deal with a specific thing rather than dealing with everything. One of the things that you will notice in this particular area is, again, detailed exception messages, so we can actually tell the user what's going on and give them a way to figure out, okay, where the hell did this come from? How can we align some of these things so that we can provide the user with useful information so they can troubleshoot these things. Is there anything with context in here? Doom, 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 doom. Complex data, features. No. I wonder if I found a way around that. Anyway. So yeah, this is going to be some of the most complicated codes. The place where most of the hairiest code lives is in the resolver. Interpreter. It's not called resolve anymore. It's called interpreter now. Yeah, .resolve. Hey, so this is where we end up with some of the more complicated code. And again, lots of detailed exceptions, providing people the information as to what the hell's wrong. And then we end up in this giant mess where we do the conversion to the best of our ability from one data type to another data type. And then at the end, if it doesn't figure it out, it just returns this exception. There are lots of conversions you think ought to work okay. They don't. You have to do some additional work to support that. Yeah. The interpreter is some of the older code in this thing, and it probably needs to be split up into multiple pieces and have better test coverage on it. Because this is the thing that I had to write in each of the different projects in the past. This is the thing that I've written for the 4th time, which means that I didn't put as much test coverage on this as ideally would have if I had written something like this for the first time. So this is one of those cases where it would be good to break it up into separate pieces, but because it is so far into the guts of the system, I'm not exactly keen on opening it up unless I have a pretty good reason to start mucking around in here. So yeah, that is pretty much the deal with variables in the entire variables folder. It is hairy, it is the oldest part of the system, and it supports a lot of the core functionality, but it also hasn't had many issues. So that means it's just kind of being left alone and stays the way it is. Object view. This is something that is, I believe, related to the PossumLabs project, right? That web app thing that you've never seen. The object view is a way that we can shuffle data to the user interface so that you can actually see what the values are of variables, similar to how you would be able to watch variables in Visual Studio. So that was in there to support that particular behavior. Object factory just creates instances to the best of its ability. Yeah, that's most of it. So the interfaces are relatively simple. You have this iEntity, which has log format, which is an inheritance of iValue objects. So go to the definition of that guy. And I believe this has nothing. So that's just the marker interface. So why iValue and entity? What's the difference between these two guys? So entities are things that have states and names, whereas values don't really have names, right? So a value could be 42, whereas an entity could be a user object, right? It has an ID in a database, whereas the number 42 most likely doesn't have an ID in the database. It's just too simple an object. It's not really something you refer to in that particular case. Now, for instance, an address, as far as your tests are concerned, isn't something that has an ID, right? It's not like, hey, there's a specific address and we actually correlate things back on the same address. Now, when you look at the actual implementation, of course, it might be that that address is only stored once and there's a many-to-many relationship between users and addresses. But again, that address would probably be a value object for the context of your test, whereas the user is something you care about a lot more. You treat that much more as an entity, as something that you have an ID for. So that's kind of the concept between the two. This is why entities have log format, and this just runs at the end of the test and spits out a log message for each entity, so you have better information automatically built into your system to debug and figure out exactly what's going on with your test cases and what data was created. So that's where that comes from. Yeah, if there's a specific topic that shows up in the future, I may create a separate video just dealing with this particular part of the project. But I imagine it is very unlikely that anyone has to go in here, because I haven't been in here in months. So that's a pretty good sign. And that kind of wraps up the first project. So yeah, I'm sure not as exciting as the previous videos. The last thing I want to cover is these integration tests and unit tests. Integration test is building up your test to the point where you can actually run some feature files. Right, so it's a little bit higher level. I wonder if this does some templates, some validations, existing characteristics. Yeah, it doesn't do a whole lot. So it's just primarily dealing with data in this particular case. This is not dealing with Selenium in this particular case, but I believe at one point it did. Whereas the unit tests are much smaller scoped, or they are testing interfaces that are, or doing effectively integration tests of interfaces that are intended for consumption by just code. So that's very fluid data creation. It lives in here and not in there. Ought that live over here? Yeah, maybe. I don't know. Lots of things I'm not going to worry about. This can be deleted. I did run Striker at some point. Striker doesn't work well with extension methods, so it had a lot of false positives. A little bit frustrating in that regard. Oh well. Yeah, so that wraps up most of what we're dealing with here in these particular videos. Again, this is going to be not as riveting content as the tutorials, but it should give you some general idea of different bits and pieces of the system, what lives where, and some tidbits of what's going on. Again, if you have any specific questions, feel free to leave a request. We can always have a video call to go through some of the specific areas, and I wouldn't be surprised that this video gets re-recorded in a number of months and we'll have some better content in here. But it at least gives a starting point. Well, if you're still with me, thanks for sticking with it. I appreciate it.